All righty, I think we are live now. Welcome everybody. Good morning, good afternoon, good evening, wherever you are. My name is Mark Pastor. I'm with Western Digital. I'm a Director of Platform and Product Management and Marketing. And joining me today is David Gerstein from Lille Storage. Hello, David.
Hi.
And today our topic is going to be how to leverage SMR hard drives for high performance computing and service provider use cases. And this is an incredibly important topic because we'll tell you a little about what SMR drives are. And it takes some special software to make them work properly for data center use cases. And Lille Storage has provided support for these drives in their file system that David will talk a lot more about. And that means that you can easily leverage SMR technology to increase your capacity and density of storage. So I think this is a super important and relevant conversation for today's market. In today's presentation, I'll walk through quickly, as I talked about, what SMR technology is, just to give you a sense of that, and why it does take some special tools to take advantage of it. And then David will go into Lille Storage's system that supports this called Sana FS. We invite you certainly to ask questions throughout. There's the little Q&A button, question mark button on the somewhere on your screen. If you type in a question there, we should be able to see that. We've also attached some special resources. We have a solution brief, a link to further explanation of SMR technology, and some other things as well. So let's get going on to the content. All right, so what is an SMR hard drive? So SMR stands for Shingled Magnetic Recording. You can see that described and defined in the second column of the text down below. But basically what it is, it provides for overlaying tracks of data to make them even more tightly packed on the hard drive. And so that allows us to increase the density of the hard drive. And so you can get the highest capacity of hard drive technology by leveraging SMR technology. And that compares to the more conventional magnetic recording, which we refer to as CMR. So you can see the diagram of a CMR drive, which is the stripes that you see on the box in the center. And then the SMR depiction shows those stripes overlapping each other. And that's really what host managed SMR is all about. It's really what SMR is all about. Now, there's two ways to control that. One is drive managed versus host managed. For virtually all data center applications, we prefer host managed SMR because that way the software, the person driving the drives themselves can control the performance experience and expectations and get a lot more out of the reliable experience. Some drive managed SMR is done more at the client side, but for the intents of this discussion and really for most data center applications, host managed SMR is the way that SMR drives are controlled, and Sana FS does that. So I think that, there's a lot of technologies that go into our drives. I think the next slide talks a little bit about that. So we call this Ultra SMR at Western Digital. It's because we have a lot of other sub technologies, triple stage actuators, OptiNAND technology, which is really important. We've integrated some NAND flash into our drives to really help the reliability and even improve our performance and density of drives. So there's a lot of technology that goes into the drives, not just SMR, but when we talk about Ultra SMR, we mean the shingled magnetic drives with the addition of all these additional technologies that allows us to deliver really the highest capacity drives out there today. We've announced up to 32 terabytes on a single hard drive, leveraging SMR technology. So I don't want to spend too much time here. We've given you a lot of pointers in the references that you can go to. And I think from there, and here's a discussion about the drives that we have recently introduced. So 30 terabyte and 32 terabyte drives. We also have 11 platters in our drives, so we're the first to introduce that. So we continue to do everything possible to improve the density and dollar cost per terabyte of storage, leveraging our hard drive technology. So with that said, now the question is, how do you take advantage of that? So you get the lower dollar per terabyte, and of course, the reason density is really important is because of the infrastructure savings. So if you can pack more capacity into a single platform, then you need less platforms, and therefore you need less infrastructure. And so not only do you get lower cost on acquiring the capacity in the device itself, but if you can squeeze more capacity in fewer boxes, then of course your infrastructure can be less, and you can manage your storage space and everything else. And so it really helps keep your costs down, and as well as your power and all the other infrastructure things associated with that.
Mark, I think we need to provide a kind of example here, like,
oh yes,
this 32 TB SMR drive sharing the same mechanical platform with the 28 TB CMR drive, meaning that we have 4 terabytes for free because of capacity delta that is unlocked by these SMR tracks overlapping and so on.
Yeah. Thank you, David. Yes, I'm going kind of fast. We've got a lot to talk about, but David brings up an excellent point. So in today's technology, an SMR drive will deliver 32 terabytes compared to the largest CMR drive, which I think is 26 or 28 terabytes at this point in time. So you get 4 terabytes more in a single device. And so when you multiply that out, it really improves the overall density. I'm going to move here too to talk about our platform. So I talked about our devices. We do have our JBOD platforms, which we call the UltraStar Data family. On the market today, we have the UltraStar Data 60 and the UltraStar Data 102. The Data 60 contains 60 hard drive or capacity for 60 hard drives, and the Data 102 for 102 hard drives. There's been a lot of innovation that's gone into these. Just really briefly, I'll talk about some of the key ones that we talk about as ISOVIBE. So if you look at the image on the upper right of the screen, you can see that we actually have cutouts in the circuit board where the hard drive actually mounts. And so that actually provides vibration isolation from the hard drive to the rest of the system. And so any hard drive then has less influence from all the surrounding hard drives, the fans, and everything else. And so we've done a lot to reduce vibration at the hard drive level, both what the hard drive puts to the rest of the system and what it experiences from the system. In addition to that, we have our Arctic Flow technology, where we have created actual airflow channels within the system. And this is a pretty unique patented system where we actually take cool air and we channel it through different zones of the hard drives. So in a traditional system, you might have the cool air coming in, and as it hits the first drives, the air starts to heat up. And as it gets towards the back of the enclosure, the drive cooling at that part is getting warm air from the previous drives. So instead, we channel the air. We only channel the first part of air through the first part of the enclosure, and then we have cool air coming into the back part of the enclosure. We do the same thing, a separate channel for the electronics. And so everything gets much fresher, cool air. And so it's much more effective cooling for the whole system. And of course, that helps improve performance. It helps improve cooling energy, all kinds of things, all kinds of benefits that are associated with that. So those are some of the key innovations that we've got, in addition to a lot of mechanical features like toolless replacement items, rack-mounted top covers. So when you slide the enclosure out, the top stays in the rack, makes it much easier for serviceability. And we've got a whole video on that as well that you can find on this channel. So with that said, and then finally on the Data 60 and Data 102 platforms, I think the other thing I would call out here that I haven't talked about is we have a zoning capability, which is really important because this is all about getting the most efficiency out of your storage. And so if you can take these 60 drives or these 102 drives and break them up into zones where each zone can have a special independent purpose, maybe each zone serves a particular server, a host server, or as David will talk about in Sana FS, Leal has leveraged the zone capability to really help the overall efficiency and performance of their system. And David will get more into that as we go there. David, I don't know if there's anything else. Is there anything else you would add that I haven't covered that's important from a hardware perspective?
I think we are good.
All right. With that said, let's move on. And I think this is where, David, you can talk about Leal.
Okay, thank you. So let me introduce what is Leal Storage. Leal Storage is a scalable software-defined file storage solution that is built on top of our open source distributed file system, Sauna FS. So it's designed for many use cases such as Active Archive, backup, AI, HPC, enterprise file sharing, also CCTV, media and video post-production, and also on-premises Kubernetes storage. By supporting host-managed SMR technology, we offer this extra 40B of capacity per drive at no additional cost. And we will enable even more in future because this delta will grow with a newer generation of drives to be released.
Hey, David, why do you have some of these use cases highlighted versus not?
Yes, I will cover during this presentation only first three, but basically most of those use cases are a kind of SMR-friendly use cases, because if you think about Active Archive for backup, or you will think about secondary storage for AI and HPC, or enterprise file sharing, it's essentially a bunch of sequential kind of workloads, either reads or writes. For instance, for enterprise file sharing, people typically do not handle the random read and writes. They just upload a completely new version of the file to the storage. So CCTV is basically the same. So a bunch of streams from different cameras come into the storage. Media and post-production as well. If you will look at the video editing software, we will see that typically the raw data is untouched, and all the changes, all the editing stuff is typically implemented outside of the raw data. So most of those use cases are so-called SMR-friendly use cases, meaning that we don't need some intermediary storage like flash to land random workload and then convert it to a sequential one. So those use cases are naturally best for SMRs. And speaking about host-managed SMRs technology, we are not the only one enabler. And let's see, let's look at SMR enablers that we currently have. So first of all, let's talk about major public clouds like AWS, like Azure, like Google, Meta, Dropbox, Wasabi, Alibaba Cloud. They do support host-managed SMR drives for their services. However, what makes us different, we focus on on-premise solutions. So Leal Storage is a data storage for on-premises. And if we will look at the on-premise part of SMR landscape, we can see, for instance, that there is BTRFS, which is a great solution that enables SMR drive, SMR technology for a single drive. Basically, it converts host-managed SMR drive into drive-managed SMR drive. So you can put the data even in a very random workload way, like random writes, random reads, and the BTRFS will try to convert this random workload and land it as a sequential onto these zones that the SMR drive has. Unfortunately, you cannot use multiple drives or multiple nodes with BTRFS, so it's not really for massive SMR use, so to say. We also have CEF here, and I think CEF is well-known, software-defined storage. And again, Unfortunately, SMR support for CEF storage is not really production ready as of now, and we may expect it to be ready in a newer version of in 2 years maybe from now. So what makes us different from CEF is that we are already production ready, and we can scale across multiple disks and multiple nodes, unlike BTRFS. So this positions us as a strong choice for scalable on-premise SMR-based data storage. Okay, for many years, large technological companies with big R&D budgets have used their SMR drives in their own data centers. Now, Lail Storage makes SMR technology available for everyone off the shelf. So we remove the need for specialized SMR expertise and complex integrations, giving you a simple, scalable on-premise data storage solution. Our mission is to bring the SMR efficiency used by hyperscalers for over a decade directly to you. That's the idea.
I think this is like the key point. This is the most important benefit with Lail Storage is you can now implement this in your data center. Great point.
Yeah, so as I mentioned, Lail Storage is built on SoundFS distributed file system, and the SoundFS is a POSIX file system. It's with an open source core, so there is no vendor lock-in, and SoundFS design and architecture actually inspired by Google FS design, which separates metadata and actual data. This means that the client, which is on the top of this picture, asks a master where to read or write the data, and then directly accesses the chunk servers, improving performance and scalability. So this means that data and metadata paths are separated. So another interesting feature of this design that we have is that erasure coding actually happens on the client side, not on the chunk side, like typically implemented for some other software-defined storage solutions. So this significantly reduce overhead on chunk servers and make the storage more scalable. So let's go further. We also use CRC checks both on the client side and on the chunk server side, so the data integrity is constantly monitored without needing to recalculate erasure codes. So this is the extra insurance to keep the data undamaged. Also, we have copy and write snapshots that let you track the changes on top of existing data. So you can create a snapshot anytime for file, for folder. And this can also enable immutability feature, for instance, for ransomware protection, where you can roll back unwanted changes while tracking the storage usage. So let's go further. And the last but not least, Lail Storage extends SoundFS to fully support host-managed SMR drives alongside with the traditional CMR drives. And the most interesting part is that you can mix different drive types or capacities in the same namespace, making it easy to start adopting high-density SMR technology and optimize cost anytime. Okay. So we can mix SMR and CMR drives in the same cluster because we brought SMR performance close to the conventional drive levels for sequential workloads. Western Digital recently published a solution brief titled Lail Storage Partners with Western Digital to deliver a distributed file system enabling host-managed SMRs at petabyte scale without cloud. So it compares performance results for 60 SMR drives and 60 CMR drives on a single node. Even a single node lab with just 60 drives will achieve over 5 gigabytes per second with write speed over 6 gigabytes of read speed. As more nodes and drives are added to the cluster, SoundFS performance grows accordingly.
By the way, that solution brief that David just mentioned, that's one of the attachments that you guys can download from the link here.
Yeah, so to achieve these performance numbers that I just mentioned, we are using zoning setup that was briefly mentioned before. So we split the JBot in 2 equal zones specifically for this solution brief setup. There was 30 drives per each zone, and we had 2 SAS connections per zone, 4 in total. So that's how we boosted overall bandwidth and achieved higher throughput. Okay, so let's look at the numbers once again. And as I mentioned, we use both CMRs and SMR drives without any intermediate storage for cache purposes. And as you can see in the comparison graph, that read performance is pretty similar for SMRs and CMR drives, while for writes, we have a significant gap. So let me explain where it comes from. So because SMR data must be written in sequence, any changes or random write can create fragmented zones. And to handle this, we'll look for fragmented zones and move valid data into a fresh, empty zone. So I will provide a very simplified example how this garbage collecting and defragmentation process works. So for instance, we are writing the file, and we do write one block with 64 kilobytes, which is orange one, and then write another one, which is purple one. And then at some point, for instance, the data has been changed in the purple one. So what we can do to respect SMR technology constraints, we can only append the changes on top of already written data. So this will create a black hole, which is on reference data, and the changes here we are writing to this red block in the same zone. So now we have to eliminate this unused space, unreferenced black space between the orange and red blocks. And that's why we pick up another zone, zone Y, for instance, and just copy these blocks to this zone Y to remove the gap between these blocks. And the last stage that since now we have only unreferenced data inside zone X, we can safely reclaim space and clean the zone. So this is actually a very simplified model how the fragmentation process looks like. And as you can see in the comparison graph, that read is pretty similar to for both CMR and SMR drives, because reading doesn't require rearranging the data. However, for SMR writes, despite defragmentation and other optimization that we have, SMR drives are often show slower write speeds because they require sequential writes and sometimes need to move the existing data. So this extra step can add latency, and that's why we have the some gap for writes here.
Yeah. Hey, David, if I can point out, you and I have talked about this before. So what we're showing is that, you know, an SMR system does have some performance penalty, particularly on writes. But if you look at these performances, they're certainly still very acceptable performances, particularly for the use cases that we talked about, where it's active archive or HPC and large data use cases. So the point we're trying to make here is many, if not almost all of our users for these use cases would prioritize cost over performance, particularly if you can get this level of performance. And that's why SMR technology and the Leal storage solution is so effective, because it can deliver adequate performance and allow you to realize the benefit of the cost reductions.
Yeah, actually, absolute numbers here are ranged in megabytes, so it's over 5 gigabytes only for 60 drives.
Yeah.
With more drives added, we will have more performance.
Yeah.
So let's talk a bit about specific solutions. Let's focus on AI and HPC workloads. Historically, from 80 to 90% of HPC storage relied on tapes, but tapes aren't ideal for AI because they need fast data access and frequent model updates. In some industries, like for instance, oil and gas, tapes can fail sooner than expected due to heavy reading, even before their official end of life, because tapes were not designed for this kind of workload. So what we do here, we keep the data easily accessible without these read limitations of tapes. We offer higher energy efficiency, and we meet the growing data demand here without compromising on the performance. So one more case is our active archive solution that keeps data always accessible, always actionable, while maintaining low cost per terabyte, thanks to host managed SMR technology, for instance. And unlike tapes, we ensure fast access to your data. Unlike NVMe drives, it's far more cost efficient. And compared to traditional HDD-based storage, we're using hyperscaler technologies like SMR drives, like power off features, to reduce cost and boost energy efficiency. And the last case for today, last but not least, enterprise file sharing. So enterprise file sharing often deals with many small files, which can stress traditional storage systems. We've optimized our solution to reduce overhead for these small files, and we constantly improving our storage to handle massive file counts. Our goal is to give regional service providers and enterprises the same competitive edge that hyperscalers enjoy, at scale without strong performance. At scale and with strong performance. So why choose Leal storage? So why choose Leal storage for HPC and service providers? First, make your data actionable. We combine nearline and archive workloads, so you get quick access to raw data for modern processing needs. Second, we keep your data forever. You can easily expand or refresh capacity when hardware reaches end of life. No need for full data migration. And we optimize your TB cost by using SMR drives and power-off features that I mentioned. We achieve hyperscale cost efficiency, reducing cost per terabyte. So that's it from my part.
Excellent. Yeah, there's still time. If anybody's got any questions, please post them. If you need more information or want to know how to get any of these things or need more details, you can see we've put email addresses down below here for Leal. You can contact sales@leal.io. You can contact me directly at Western Digital if you want. There's other avenues through the website and all that, but certainly feel free to reach out to me directly. I can get you the information you're looking for or route you to the right place. I think in summary, and thanks, David, I think, Western Digital is very excited about the relationship with Leal Storage because it really helps enable SMR technology in your data center, as David talked about. And I think that's super important and critical and very helpful for a lot of you that are looking to optimize the efficiency and overall storage capacities in your data centers. So I think it's very timely, particularly as applications like HPC and AI, are becoming even more strongly implemented everywhere. David, do you have anything else that you would add at this point in time?
I guess no. The small addition is that inside these attachments that we have, we also have, aside from this solution brief that we mentioned, we also have SNIA conference materials, how we in detail implemented this SMR support on the chunks level. So if you want to dive deeper in these details, feel free to download the deck.
Yeah, excellent. Well, with that said, I thank you very much, David. Thank you so much for your time. I'm really excited about the solution that we've got. I know we'll be talking a lot about it as we go forward in the marketplace, and hopefully those of you that attended will find value in this information.
Thank you.
Thank you. Bye-bye.
Bye.